Dear students, in today's session we will discuss how we can solve a problem using chi-square test. Okay, so last session we discussed about non-parametric test, the theory part of chi-square, the different conditions and applications of chi-square. Today we are going to solve a problem using chi-square. Okay, so see the problem. A die is thrown 132 times with the following results. So the number turned up is given, that is 1 to 6 is given, and the frequency of each number turning up is also given. This is the observed frequency, and here you are asked to find the goodness of fit. So whenever in a question if you are asked to find the goodness of fit, then you should understand it is a chi-squared question. And again you can see here everything, the samples are taken in random, that is a condition for chi-squared, and definitely the number is large. Okay, the number of times the die is thrown is 132 times, so it is large. So all the conditions of chi-squared is satisfied here. Now we have to solve it. Now what is the first step? The first step is, this is actually a hypothesis testing, right? So you are asked to find the goodness of fit. So what will be our null hypothesis? Null hypothesis is that the particular die that we are throwing is unbiased, and definitely there exists a goodness of fit. Okay, that means there is no much difference between the observed frequency and expected frequency. But when you are writing the alternate hypothesis, then definitely you need to write there does not exist any goodness of fit. Okay, so the first step to do is to formulate the null hypothesis and the alternate hypothesis. And in this particular question, you can see that only one, that is observed frequency, is given. Expected frequency is not given. But expected frequency we can find out. How we will find out? Now see, this is a die. Okay, so our assumption is that it is an unbiased die. Only if it is an unbiased, then we can say that there exists a goodness of fit, correct? So if it is an unbiased die, then what will be the probability of getting each number? That means whatever be the number that we are getting, it will have equal probabilities, correct? That means the probability, once we are throwing a die, the probability of getting 1, 2, 3, 4, 5 or 6, it will be definitely 1 by 6. Isn't it? In case of an unbiased die, whenever you are throwing, the probability of getting each number is the same, that is 1 by 6, correct? Because it is having 6 phases. Now 132 times the die is thrown, that means 1 by 6 into 132 will be the expected frequency of getting each number. So you can write it down in that way. Okay, so here I have written it down. That is, first is null hypothesis, die is unbiased and there exists goodness of fit, and alternate hypothesis is that a die is biased. Okay, so if die is unbiased, probability of obtaining any one of the 6 numbers is 1 by 6, and as such the expected frequency of any one number coming upward is 132 into 1 by 6, that is 22. Okay, so for each number coming up, the expected frequency will be 22. Okay, this is how we need to find out the expected frequency when it is not given in such a question. But when it comes to a tabular form or categories and all, definitely we have another formula for calculating the expected frequency that we will discuss in the next problem. Okay, now as of now, the expected frequency is 22 for each number. So now we can write down the observed frequency along with the expected frequency. So I have drawn a table and you can see this. Okay, this is the table. This table is showing the number turned up, observed frequency, expected frequency, then you have O minus E, that is observed frequency minus expected frequency, then O minus E squared and O minus E squared divided by E. So this is same as how we are putting in that formula, right? The formula for chi-squared is that it is sigma of O minus E squared divided by E. So till that you need to put it in the tabular form, so it is easy for you to calculate. So let's fill it up, fill the table. So number turned up, you can write 1, 2, 3, 4, 5 and 6. Okay, so we have all the 6 numbers written down. Now observed frequency. Observed frequency is already given in the question. You can directly write it from the question. 16, 20, 25, 14, 29 and 28. So I am directly writing it down. That is the first one. That is for 1, observed frequency is 16. Then you have 20, then 25, 14, then 29 and finally 28. So we have written down the observed frequencies also. Now the expected frequency. What is the expected frequency? So we have calculated that for each and every number the expected frequency will be 22. Because why? 132 into 1 by 6. So you will get 22 as expected frequency for each number because it is an unbiased die. That is our assumption. Okay, now next column is O minus E, that is observed frequency minus expected frequency. 16 minus 22 you will get minus 6. 20 minus 22 you will get minus 2. 25 minus 22 is 3. 14 minus 22 will give you minus 8. 29 minus 22 is 7. 28 minus 22 is 6. So you have filled this column as well. Now O minus E squared. So now you need to square it up. So this becomes 36, 4, 9, 64, 49 and finally you have 36. Correct? Next is O minus E squared, that is this one, divided by expected frequency, that is 22. 36 by 22. So here this is 36 divided by 22 which will give you 1.63. Similarly here again 4 divided by 22 you will get 0.1818. So similarly you have to write like this 9 by 22 and so on. I am just writing down the calculated value. So the next one is 0.409. Then you have 64 divided by 22, that is 2.90. 49 divided by 22 you will get 2.22. 36 divided by 22 will give you 1.63. Okay. Now the thing is you need to sum it up. How do you sum it up? That is the chi-squared value, right? 1.63 plus 0.1818 plus 0.409 plus 2.90 plus 2.22 plus 1.63. When you sum it up, you will get 8.977. Okay, so you got this particular value. Now this value is our chi-squared value, that is 8.977 is our chi-squared value, correct? Because from the table we have summed up everything and that is our chi-squared value. So this is the calculated value for chi-squared. Okay, now you need to find out the tabular value of chi-squared also. Only then we will be able to calculate and we can say that whether we have to accept a null hypothesis or reject it. Okay, now what is the degree of freedom? For calculating the tabular value we need degree of freedom. Degree of freedom is given by small n minus 1. Now what is small n? Small n is how many number or how many samples are there, right? So here the number of items is what is given by the small letter n, that is totally 6 phases are there for a die. So small letter n is 6. Okay, are you getting? It is not the number of times it is thrown, it is the total number which is coming. Here in case of die it is how many times, how many samples are there. Okay, so this is 6. Fine. So here n minus 1, that is 6 minus 1 will give you 5. So 5 is n. Are you getting? So total number turned up is 6. So that means the degree of freedom is n minus 1, that is 5. Now we have degree of freedom. But now look at the question, whether the significant level is given or not. In this particular question, nothing is told about the significant level. Okay. But usually in order to find out the tabular value for chi-squared or for z or for t or f, whatever, we need to know the degrees of freedom as well as we need to know the level of significance. Since significant level is not given, we will have to assume that the significant level is 5%. Normally, if it is not given, we take the confidence level as 95% and the significant level as 5% by default. So you can write that we are assuming the significant level as 5. If it is given in the question, whatever is given, that has to be taken. So I hope that is clear to you. Okay, so here we have to assume the significant level as 5%. Now table value of chi-squared for 5 degrees of freedom at 5% level of significance is 11.071. This chi-squared table you can find at the back of the logarithm table. This is our tabular value and this is the calculated value. So the calculated value is less than the table value, right? So since the calculated value is less than the table value, the result supports the null hypothesis. That means here we can accept the null hypothesis. So we can say that there exists goodness of fit. So we will finally write the inference. So finally we can write our inference like this. As the calculated value is less than the table value, the result thus supports H0 and H0 is accepted. Therefore the die is unbiased and there exists a goodness of fit between observed frequency and expected frequency. This is our final inference. Okay. So in case of chi-squared, you need to check whether a question is satisfying all the requirements or conditions of chi-squared. Then we have to identify that particular problem. If it is asked to find the goodness of fit, or if the number is very large and we understand that it's a non-parametric test, then you should go for chi-square test. Okay. So here in chi-square test, first thing that you need to do is write down the formula. Okay, so observed frequency will be definitely given, and in some cases already the expected frequency also will be given. But if the expected frequency is not given, you need to calculate the expected frequency, then write it in a tabular form. In tabular form you will have observed frequency, expected frequency, then O minus E the whole square, and O minus E the whole square divided by E, and finally find the summation, and that value will give you the chi-squared value. Okay, so here the first step is to formulate null hypothesis and alternate hypothesis, just like in case of any hypothesis testing. So after finding out the chi-squared value, the calculated value, then you need to find the tabular value. Then you have to compare the table value and the calculated value. If calculated value is less than the table value, then you will have to accept the null hypothesis, otherwise reject the null hypothesis. That is it. And finally write the inference. I hope this is clear to you. The chi-square test is one of the simplest tests, but it is very important. Okay, thank you students.